Here we've got a 20 kilogram box, and it's being pushed with an 80 Newton force that's down at an angle of 30 degrees from the horizontal. So this little angle right in there is 30 degrees. And we want to know what the friction force has to be to prevent this thing from accelerating. So to keep anything from accelerating, again, that simply means my net force, remember, is ma, and if a is equal to 0, my net force has to equal 0. So that means the sum of all my forces has to equal 0. So again, we're going to talk about the forces being balanced. So that means the sum of all the forces in the x, which is our horizontal direction, has to add up to 0. And the sum of all the forces in the y has to add up to 0. So there's our starting point. There's our conditions that we have to meet. Now we want to know what the force of friction is that acts on the box. So I've taken the liberty of drawing the free body diagram, and you can see the forces that are actually present beyond the 80 Newton force that's at 30 degrees. So I've got this little 30-degree angle right here. There's our original force. It's obviously going to try and drive the system to the right. It's going to slide the thing to the right, so friction's going to oppose the motion. Friction's always parallel to the ground, so my friction force is as labeled. You can see it, parallel to the left. Now W stands for the weight of the object, so this W here is Fg, and to calculate Fg I simply go m times 9.8, which happens to equal 196 newtons. Now I've also got a normal force that's acting up, and we'll talk about that a little bit later. So if we're trying to figure out our force of friction, we can see that it's a horizontal force, so let's start there. Let's start with the horizontal direction. Now, we're all good to go. We've got normal force and weight that are perpendicular to the motion. I don't have to mess with those. Friction's already parallel to the motion. Once again, there's one force in here that I have to mess with. I have to figure out the components that are both perpendicular and parallel. So with this 80 Newton force, there is a perpendicular component, which I'll put as a line this way, which I will call Px. It's pushing the thing to the right. And also is a vertical component. And because this force is downwards, there is a Py in the downward direction. Now remember, the original vector always has to be the hypotenuse, and your components are always 90 degrees to each other. So I've got Px, which is the yellow one, Py, which is the blue one. Now I want to focus only on the horizontal, so I want to focus on Px. So our conditions horizontally are the sum of all the forces in the horizontal have to add to 0, which simply means Px, which is trying to push the thing to the right, I'll say the right direction is positive, minus force of friction has to equal 0. So in other words, Px has to equal the force of friction for this thing to not accelerate. Well, how do I figure out Px? Well, if I look at my diagram, my angle is 30 degrees, which is right in there, and Px is adjacent to it. 80 is the hypotenuse. So to find Px, I want to use cos. Cos of 30 degrees is adjacent over hypotenuse. So Px will be 80 cos 30 degrees. So this is 80 cos 30 degrees, which is my force of friction, which is 69.3 newtons.